Okay, so I think we are live. Let's start. So I think we are a bit late today. Usually we stream at 7 or 7:30. So okay, so we were solving three problems. We skipped these three easy problems. We will come at these problems later. So we will today start with validate binary search tree. Till now, there was only one problem which I haven't solved from this sheet, which was car fleet, which was from stack, I think, which is from stack. So validate binary search tree. So given the root of a binary tree, determine if it is a valid binary search tree, BST. Okay, a valid BST is defined below. A left subtree of a node contains only nodes with key less than the nodes key. Okay, right subtree contains only nodes with the keys greater than the nodes key. Okay, both left and right subtree must also be binary search trees. Okay, so basically we need to validate a tree whether it's a binary search tree or not. So a binary search tree, in a binary search tree, for every node its left children has a smaller value than it and its right children has a greater value than it. So wherever this constraint not gonna match, we will return a false, otherwise we'll return a true. So that's what question is saying. So here in the first example, our root is 2, so we'll check whether its right value is greater. Yeah, 3 is greater. We'll check if its left value 1 is greater. Yeah, it's greater, so we are returning true. In second example, we are checking for 5, so we'll check whether means all values in present in the right should be greater. So we will check for 5 whether 4 is greater. Yeah, 4 is greater. No, no, 4 is not greater, so we will return false. Okay. The number of nodes in the tree is in the range 1 2. Okay, we can solve it in n square. So okay, now to value. Okay, let me first see some examples myself. Okay, first approach is, so I'm thinking of a approach. So the uh, in order transversal. For example, if I do in order transversal, So basically we have three type of transversal. Let me. So we have first transversal is let's say pre-order transversal. So pre means pehle. So this is in reference with the root node. So first our root node will come, then left node, then right node. Then post order means after. So left node, right node, and root node. Then comes my pre-order, post order, and in order. Order. Okay, so means left, root, and right. So what I am trying to say is that for this tree, if we find in order transversal, if we print left first, which is 1, then root 2, then 3, then the in order transversal of a binary search tree is always a sorted array. So that's I'm trying to say. So we can find in order transversal of a binary tree in, and we can store it in a list, and then we can check whether it's a sorted array or not. So one way is this of doing this question. So let's write this approach. In order tree node root. Okay, so if my root is null, then I will return 0. Sorry, I will return. Otherwise, uh, I will move to its left part. So I will iterate left part. First I will go to left part, then I will add current node's value, means left part, root, then root dot right, then right part. So basically left, root, and right. So this is a in order transversal. So if I print my list of, sorry, system.out.println, I print my nodes. For now, let's return something, return false. Let's see what we are getting. Okay, so for test case 1, we are getting 1 2 3. So we are getting a sorted list. Okay, for test case 2, we are getting 1 5 3 4 6. So we are not getting a sorted list. So that's why we are returning false. Okay. So what we can do is we can I nodes dot length I smaller than nodes dot size, I think. Okay, I plus plus. So I will check if my current element of my list is not greater than previous element of my list. In that case, I will return false. That Wait a second. I will return false. That the list is not sorted. So list should be strictly increasing as per the question. I will return true otherwise if my list is sorted. Okay, so we have a summation which is 15% faster. So the this takes big of n time, and this also takes big of n time. So approach is of big of n complexity. So basically here our time complexity is big of n, where n is number of nodes, and space complexity is also big of n, as we are using a auxiliary list. So we need to think of a solution where we don't need a additional space. So let's think of that solution. Mm, can we think of a solution? We need max value from the right and minimum value from the left, and minimum value from the left should be smaller than the current node, and maximum value from the right should be smaller than the this node. Then we will be able to solve the problem. So how in recursion we can return both maximum and minimum value to the left and right of a node? We also cannot take global variables. Hmm, let's see. Let's take this example. 3 6. From left, we only need minimum value. Okay, so I'm thinking of a solution where we can pass parent node. So let's remove this solution. Okay, so I'm thinking of passing a parent to the recursive calls, and I can check if a element is a parent's left children or right children. If the current element is parent's right children, then I can return the maximum value from the right, and if it's the left parent, I can return minimum value. Let's try if this works. I have no idea if this gonna work or not. So let's call this function as return find validate bst validate bst b. Okay, so validate bst, I will pass root and I will pass the parent node. Let's call the initially the parent node should be p node -1. Okay, bool public void validate bst. Let's call it tree node root, tree node parent. If root is null, then I can simply return. Let's say we deal in int values, then I can return -1. Okay, otherwise validate BST. I will move to the right part, left part, and parent for the left part will be root. Then I will move to the right part, root dot, right, and this will be okay. Suppose this returns my minimum value, this returns my maximum value. So suppose if my minimum is not equal to -1, which will be -1 in the case when left part reaches null, and my root dot value is greater than, is smaller than equal to my min value, then in that case not a valid tree, valid BST, not a BST. And if my maximum value is not equal to -1, and then my root dot value is smaller than or equal to maximum value, then in that case also my tree will not a BST. Okay, and at last what I need to return, I will check if my parent dot value is not equal to -1. So then if my current value, okay, so I my root have some parents, so if my root dot value equals to parent dot left dot value, means if my root node is left parent, then in that case I will return minimum of root dot value, and minimum till now I have received. Else it means it's what I can say right children. So in that case I will return the root dot max value, root dot value and max. Mm. In this case what I will return, okay, let's say I define a variable is BST as true, and a boolean if I reach this condition. I can define this condition in a single if statement. Then in that case my BST will become false. So I will return if my BST, then I will return 1, then otherwise 0. So what I will return here, if it's 1, then in that case I can return true, otherwise I can return false. Okay, so we are getting false for this. Getting false for this part. Suppose we are passing root, so our root is not null. Okay, so in the case of minimum, we can get -1 from here. This can cause a problem. If our min becomes -1, in the case of min, we have here a -1, and this function can return the -1 value. So we don't want to return the -1 value. In the case of -1, we need to change it to max value. Let's change it to integer dot max value. Let's see now what I'm running, bro. What I'm running. In the case of max, it can work because we are taking maximum value. Okay, it's still not working. Let's try run for this part. So we are at 2. We will move to the left. Okay, we move to the left 1. Now we will, now our root is 1. We will move left of the 1. So our minimum becomes these two functions for the 1 will return -1 and -1. So we will update nothing. So this statement will not run. And this statement is true, will follow. And in the case of -1, we have set our value to integer dot max value. Okay, so we will check if our parent dot value, no, its parent is 2. So we will check if our root dot value is parent dot, yes, it's true. So math dot minimum of 1 and minimum is integer dot max value. So we will return to the left call of 2, we will return as 1, and similarly to the right call We'll compare 3 with minus 1, so we have 3. So this right part will give 3. Okay, 1 and 3 we are getting. We will check, yes, our minimum is 1, not minus 1. We will check if our root dot value is smaller than equal to minimum. No, it's not smaller or minimum. We will check. Okay, I think it should be greater than or equal to. Hmm. Let's see for this case, 5 for 5. I think we should just print system dot out dot println. We should print our current root dot value, and then we can print its left part. Then we can print its right part. Sorry, minimum part and maximum part. Let's run. Okay. So for 1, left and right are minus 1, which is true. For 3, left and right are minus 1, okay. For 6, left and right are minus 1, okay. For 4, left part is minimum is 3, maximum is 6, which is true, okay. For 5, uh, left part is 1, okay, and right part is 6. So here it should fail, and it's not failing. Why it's not failing? Let's see. Suppose for 5 we come here. We check if 5, let's see which node reaches till this position. Println root dot value. Let's comment out for now. Okay, 5 reaches, 2 reaches, so this is true. 5 is compared with 1, so 5 is smaller than equal to 1. No, it's not smaller than equal to 1, so this becomes false. Okay, 5 greater than equal to 1. No, this also becomes false, so bst remains true. So if is bst, then we will return 1. Okay, in the case of 1, we are returning true. So why our function is not working as expected? What error we are leaving? What's the issue? True. Is bst true? Okay, I think we need a global variable to update. Okay, this should work, this should work, this should work, and this will gonna work. This is not working. I remove that check. Hmm, we need minimum value from the right, and that minimum value should be greater than the. Okay, so we need minimum value from the right. So we need minimum value from the right and maximum value from the left. Okay. So we are checking if root dot value, yes, it's a left parent. If root dot right that value, okay, if our root this value is left value, yes, it's left value. So what we'll do, we will do max of this value. Its left part will be -1. This part also will be minimum part will be -1. Okay, so in right we have three value as the minimum, and in left one value as the maximum. So so if our minimum value from right is greater than is smaller than or equal to our root dot value, then we will have a false value. If our maximum value from the left is greater than or equal to our root dot value in dot equals, also we have a. I should have commented this out. Okay, we are getting exception for 1 null and 1. How can I visualize this tree? I think I can visualize it in test case part. Okay, so one having parent as right. So what we're gonna do? Gonna pass one. Okay, we have one. We'll go to its left part. Okay, we have come out its left part. This will return -1. So max is -1. We'll go to its right part. So in right part, these two values return -1. Okay, so We need to add a check here. Now we can submit it peacefully if it works. Hope it works. It doesn't work. It's not working. Okay, we can have negative values also. I think this is not a valid binary tree. Okay, for 4 left, nothing left. Let 7, 3, 7, same. For 6, minimum is minimum on the uh, right is 7, maximum on the left is 3. For 5, it should be 3 instead of 6 here. Okay, so suppose for 6 we go on to the left part, which is 3. For 6 we are getting a maximum value on the right as maximum value on the left as 3 and maximum value on the right as minimum value on the right as 7. Okay, so our parent of 6 is not -1 and left is not null. Okay, so this is our right children. So if 6 is right children, then in that case, okay, so we should return math dot minimum of min and max and math dot maximum of min and max. What I'm doing, I still don't know. I'm feeling sleepy. No, we are getting correct answer for this case only. For my left part, left is not null. Left is null, so my right part min value. Unicorns max value. Okay, so we have this solution which GPT has provided us, where we are using lower and upper bound, and we are moving from up to down. So initially we don't have any upper and lower bound. So suppose we move to the left part. So we moving to the left part, we will update our upper bound. So now our upper bound is, mm, let's copy this code and paste it here. So for this part, we are here, our lower and upper bound don't update, so we'll move to the left. Now we are here and our upper bound is 5. Okay, so upper bound is 5. So if our roots value is greater than upper bound, then we will return false. Similarly here, now our lower bound is 4. Okay, 5. So our value should be smaller than our lower bound. Yes, it's smaller. We move to the left part and we make our upper bound as 4. So our value with should be within range 5 and 4. It should be smaller than 5 and also smaller than 4, means our lower bound is 4. When now we move to the right. Okay, we move to the right, our lower bound becomes 4. Wait a second. We are here and we move to the right, then our lower bound becomes 5. So if our value 4 is smaller than lower bound 5, okay, basically we are maintaining a range. Okay, now moving to the right of the 6. While moving to the right of the 6, our value should be 3, 6. So in the case of 6, we will update our we move to the right, so we'll update our lower bound to 4. Okay, so and 6 is not smaller than 4, so this is breaking our lower bound. Okay, so this is a perfect approach, I think, using lower and upper bound. Let's see previous submissions. Okay, is valid PST. This is an square approach. Okay, so we should mark this question. So I think that is it for today. Hmm, or we can solve something else. Okay, so that's it for today.